Work done when force is perpendicular to motion. Till now we have seen when the work is done at an angle to the direction of motion. Now we are seeing when that angle becomes 90 degrees. So when force is oblique to direction of motion, we said work done is F cos theta into S, where F is the force acting at an oblique and theta is the angle between the direction of motion of a body and the force applied, direction of the force applied, and S is the distance the object moved. Now, if theta is 90 degrees, when force is perpendicular means when theta is 90 degrees, that means the angle between the force, the direction of force and the direction of motion is perpendicular. Then what happens to work done? Work done becomes F cos 90 into S. Cos 90 is 0, which becomes 0. So work done is 0 when theta is 90 degrees. So we can say that when direction of force is perpendicular to direction of motion, work done is 0. An example, we can say a person carrying, which we see in all the railway stations, person carries loads of luggage. What happens? It's an example where the suitcases do not move. And in this case, the direction of force and direction of motion is perpendicular, because displacement of the body is perpendicular to the direction of the force. Then no work is done. So when a man is carrying these suitcases strictly horizontally, and not at an angle, we'll say that he is holding it in a very horizontal way, then he does no work with respect to gravity. Why? Because the force of gravity acts vertically downwards, and the angle between the displacement of the suitcase and the direction of force is 90 degrees. Because there is no displacement of the suitcase, and the angle between displacement of the suitcase and the force of gravity is 90 degrees. And hence, this is the force of gravity, if you say. And if this is the displacement, because the man is moving and the suitcase also is moving with the man in a horizontal manner, then the angle, this is the motion, angle is 90 degrees and cos 90 is 0. So work done in this case is 0. So there is an example to understand how in our practical life work can be 0 even if a person is holding the suitcases, holding the weight. So the same thing happens in many of our daily lives, like we are sitting and watching the TV, we are not doing any work. It's all because of this particular situation where direction of force is perpendicular to motion, wherein force of gravity, direction of motion is perpendicular. What happens when work done when the force acts opposite to the direction of the motion? When force acts opposite to the direction of motion, opposing, what happens to the work done? Formula. Work done becomes the force is minus F into S. How? Because we know that work is F cos theta into S. Now what happens to theta when it is opposite to each other? Because force is in this direction and motion is in the opposite direction. Then what happens to theta? 180 degrees. So W becomes F cos of 180 to S. And cos of 180 is minus 1. So this becomes minus F into S. So minus F into S. So it's obvious that the work done by the force in this case, where force and motion are opposite directions, it is negative. W is minus F into S when both the directions are opposing. That means theta is 180 degrees.